Let's give it a couple seconds for everything to work. Alright. Alright, that should be enough time. So this is day 3 of working on LeetCode to help me prep for my OAs at IBM, TikTok, and Roblox. Hopefully Microsoft gives me an OA too. Alright, so we're gonna pick up where we left off. Trapping rainwater. This one's a hard one, so I'm gonna just skip that for now. So let's do this one. Nice easy one.
Keep it up, peak pie. Conflexed bicep.
Alright. So best time to buy and sell stock. You are given an integer array of prices where prices I is the price of the NeetCoin. That's nice. On the ith day. You may choose a single day to buy NeetCoin and choose a different day in the future to sell it. Return the maximum profit you could achieve. For you may choose not to make any transactions, in which case your profit would be 0. Okay. So in this example we have 1, 2, 3, 4, 5, 6 days, and the price is 10 on the 0 day, 1 on the first day, and so on. So it's getting 1 and then 7 to get 6. So the profit is just the selling price minus the buying price. So 7 minus 1 is 6, and that's how we got the output. Yep, as explained down here. So let's see. Okay. So let's see. So we can't sort it because these are just days. So let's see, how would we do this? Okay. Since we always want to buy at the lowest price, then I guess we could have some indication of the lowest point, and we want the highest price to make max profit. So we'll have another indication for the max price. So we'll do like, we'll check this. So kind of like a 2-pointer. So let me just write out 2-pointer code real quick. So we got the left, right, and the left is 0, and the right is the length of prices minus 1, and then while the left is on the left side of the right. And basically what we will be doing is let's see. Okay, Okay, let me just think about this for a second. So how would we know when to go down the right, like lower the right pointer, and when should we go up the pointer, like move the left pointer up? So let's say we started at 10 and we look at the next number, which is 1. So here the profit would be in the negatives, so we just move up our pointer. Now we're here. And then we look here. We notice that we get some profit, so we keep on going. Get some profit, keep on going. We see profit, keep on going. And here is where we stop. So we could move up this back pointer, and actually we don't even need to move this back pointer. We could just start at this new pointer. So we could remove this pointer, remove this pointer, remove this pointer, and until we get to here. So let's actually change this up and start on zeros. So it looked like we did like a for loop. So we could do left is equal to 0, and for let's do enumerates, and in enumerate prices. So we got our index and the value. Now from here, let's implement the logic that I said. So that would be so we have the left and the right, right? So currently we both have it at 10. So at this point, I could say if we could try calculating profit, maybe. So what I'm thinking is we could do n, or let's actually change this to right. This is the right index, and then this one is the number. So if the number on the right is so the right has to be bigger. So if n prices at this left side, so the left has to be shorter than the right. But if it isn't, we have to move the right pointer left. Okay, I gotta think about this condition. Okay, let me just skip ahead a little bit. I'm getting confused. So All right, let's say we were here again. So we're at this point. Oh, okay. I think I got it. I think I remember. So, um, so if the right, if the left side is greater than that, we'll continue it. And if it's not, then oh no, I messed this up. If the left is bigger, then we will move the pointer up, the left pointer. And if it's and then we have to keep track of the biggest result. So let's do the res, and right here okay, this has to be out because no, it's not. So once we have this, we have to make the left equal to the right. And we will update else it will continue. And at this point we will let's update our prices. Our result. So result is equal to the max of our window, which would be the result or the right minus left. So, and then at the end we could return the result. Damn. Okay, let's work through this again. If the price on the left is greater than, I think that's supposed to be greater than or equal to, or not. It's just returning 1. So if the prices on the left is, oh, we forgot to increment. Okay, that's not working. If the price is on the left, so our left would be right here, and our right is on the same position. Now we move on. We look at these two. We're here. Look at the next one. If so, here, then here. What is that condition? Is it like on left? Do we continue? 10. Okay, and then we have write it right here. Or do we check the next one?
Now, regardless.
Okay, let's use this as a hint. So we have the left, right, 0, 1. And then we have the results, which is equal to 0. We could return the result then, but next we have to do while the left is on the left side of the right. What would we do?
Has not passed the end of prices. Now, I want to shift it fit for us. You don't basically want our left pointer.
Okay. Okay, well, the right is on Len. Okay, so if prices on the left is less than the prices on the right, so this is saying the left is less than the right if that is true, we will update our profit. Bro, I swear, I basically had that. Like, I'm not even lying. Profit is equal to, what is our profit now? Profit, it's prices of the right minus prices on the left side, and we will update our result to the max of one of these two, the result or the profit. So there we have that. And from here, if it's on the right, else we, like if the right side was bigger this time, as we could see like in the video or right here, so if this one was bigger, then we will have to make the left pointer equal to the right pointer. So it's kind of like resetting it. And then we will update our pointer, our right pointer. Oh, that sucks. Okay. So I believe I could do better than this. Like really bad. This is really bad. Okay. Well, it's not really bad, but I think let's try using a for loop. So for I, well, let's call this R and M in enumerate left and right, or profits. So instead of using this, we'll do N. Kind of want to change this. Let's call it, oh man, I can't change it anymore. Okay, perfect. So let's call this right price, our price. So we got our index and the right price, and basically what we have here, yeah, the only problem is this part. I need this to start at 1, because I'm pretty sure this won't work as is. It's equal to 0. Oh, it's called prices. Oops. Does it work? How does that work? So our right is bigger. Oh, I see. I just forgot this bottom part. Oh, I feel so dumb right now. Okay. Alright. So we got left pointer, the result for our index and our price, and enumerate prices if the left price So if the left price is less than, okay, let's be more explicit here so I know what's going on. If the price on the left side is greater than the price on the right side, then we'll update our left pointer is equal to the right pointer, and if it's greater than or equal to, we'll update the pointer. It kind of looks cleaner the other way around. If the prices on the left is less than the price on the right, then we want to, what do we want to do? We want to update, what do we want to update? So our for loop is moving the right pointer. So right here, we just want to update the profit. So we do 5 minus 1, that will give us 4. And then we update whether or not it's the max profit. And then in the next iteration, the right pointer will move here. And so on till we get here. And then once we check this one, so here's the right, here's the left. If they are equal to each other, so the left is not bigger than the right, then we update both. We update the left pointer to just include. So we had this, now we go here, 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 all the way back. And then we update the right pointer, but the right pointer is finished. So do we even need this? Where's this from? I'm wondering, do we still need this one? My question is, do we need this part? What? So we're here, we update left and right, and let me ask ChatGPT. I think we're skipping. Two-pointer / sliding window. Okay. So this was more like a sliding window one. Although this is kind of two-pointer-ish. Two-pointer is more like left and far right. But in this case, the right was like right next to it. Hence the sliding window pattern. Okay. I think the only reason why it ran faster is because I have no idea actually. Let's ask ChatGPT. Why does it run faster with with r plus equals 1. Why does it run faster with this? That's what I'm saying. Why is this running faster? It's one of those confusing things. But, oh, we're back on first place. Nice. Okay, well, there is my solution. Sliding window is mainly written like this. Of course, you could use the 2-pointer way, which is slightly more cleaner. One sec, I have to do this and this. Alright, so I'm thinking one more and then we head out. Longest substring without repeating characters. You're given a string S. Find the length of the longest substring without duplicating characters. A substring is a continuous sequence of characters within a string. Okay. The string AXYZ is the longest without duplicates. XYZ. So right here. So let's think. Let's just try running it, I guess. In my head. So let's look at this first character. We move on to the second one.
What up?
Hey. So these are not duplicating characters. We move on to the next one. This is not another. Yeah. Then we move on to the next one. We see Z is being duplicated. Hey. Hello. Okay, and then from there, I'd assume that to remove that duplicate, we'll just move up this pointer. The left pointer up. And then, boom, we got XYZ. And then we move up the pointer again to keep on going. We see Z, another duplicate, move the left pointer, go up. And same process with Y and Z. Okay. And we're returning an int. Alright, hopefully that makes things easier. So let's make a result, which is just gonna be an int. And we know that this is gonna be like a sliding window. So I'm gonna write down like just the basic format of it. So I like using enumerate here and enumerate the string. Okay, and then we follow the logic that I said. So we need a way to keep track of the characters that we've seen. So let's use a set so we could have constant lookup times. So let's just call this scene, which is a set. And basically what we would be doing, oh wait, what is this? That should be left. So the left and right pointer are pointing at the same thing currently, and I'm gonna just assume the right is 1 just so I could kind of see what the condition is. So if the right element, so the right letter, let me write letter here, or should I put C? No, that's fine. If the, let's do right letter. So if the right letter, oh my god, what the heck, is in the set, if in scene, then we want to remove that. Yeah, we want to remove it from the set, like the previous, the left side. How would I explain this? So like for example, we have x, y, and then once we get to z, we run this if condition if the right letter is in z. So it is in z since it's highlighted. We want to pop that so that we could just look at these. So we'll do scene dot, I think it's pop or remove. Let's try remove, and then we'll just remove this letter. And at that point, we could also move up the pointer. And let's see, what else do we do here? So we're right here. We seen that character, so we pop it off, we move the left pointer up, and yeah, I guess we move on to the next iteration, which I would do using this. Oh, we have to add the character that we didn't see. Well, the character that we're currently at. So we'll do scene that add this character. So we'll do this, and we also have to I think we're supposed to update the result here. Result is equal to the right minus left pointer, or the max of these, max of the results, and then we'll return the results. Okay, so what we have here is if it sees like duplicate right here, which in this case is Z. We remove it from the set. We move the left pointer up, and oh yeah, we also update our I don't think we updated there though. Oh no, we do. Okay, and then we update. Wait, we're at here. 4 minus L, or no, okay, this is not gonna work, I'm pretty sure. Yeah, we're 1 up. So we're placing this at the wrong place. And this does not look great. Yeah. Okay, I'm just guessing here, but we're very close, I could tell. So results. If the right letter is in scene, if not, am I supposed to write an else here? No, it doesn't really matter. Does it? Pretty sure it does matter. Yeah, it does matter because we had to remove the last part and add the new part, the new Z. Okay. So we're left with this. Okay. I think we're just supposed to do it right here. Okay, let's try running this in my head. So we both start right here. This is 0, left and right is equal to 0. And then if the right is in scene, it is not. So we update the max to right minus left. What if it was just S? Or what is this? Output. So FS. Okay, I think we have a slight mix up here. Let's try running this one. So we got X. And then okay. If the right letter is in scene, remove it, update pointer. No, let's not do that. So it's not in this. So let's update the max that we've seen. I don't think anything else is gonna fix this, is it? I doubt it's gonna fix anything. Yeah, okay. Huh. Result 0, right minus left, that's 0 minus 0, res, letter, add to scene, the right letter, or, oh wait, is it supposed to be the other letter? I think. So this is S. Okay, I definitely messed up right here. This is supposed to add the left letter. Or no, I'm messing up again. Bro, okay. No, it is the right letter. There's something wrong right here. I just don't know what. Add the letter. I don't think this is right. Okay, now we move on to the next letter. Okay, it takes care of this case, but it doesn't take care of this one, so let's try running this. We're at 0, 0. If the letter in scene, no, that's not possible, so we add the right letter, P. The length of scene is now 1. So 1 gets updated. Now we got R. R is right here. If the right letter in scene, it is not. So we move on to here, scene dot add the right letter, which is W, and we take the length of what we've seen, updated the result. Now we are on W again. If the right letter in scene dot remove the right letter. So it removes this letter. Oh, I don't think that's right. Okay, I think this part is wrong. Okay. So I think what we can do here, since we're at this point and we see the W right here, we have to close the window. So we have to find a way to go here and then here. So we could do this with a while loop inside. So if the letter is in scene, we will traverse this so how would we do this though? Well, the character on the right, the left, is well, it's not equal to the right letter. Then we could keep updating the left pointer until it does equal that pointer. And then at that point we can remove it. That looks more promising. So it'll keep going. So we're here, it'll keep going. So the left pointer right now is not equal to the right pointer. So that's just saying P is not equal to W. So we move the left pointer up and do the same check again. The left pointer is equal to the right pointer this time. So we remove that. Okay, and then scene that remove right letter, which is the same thing as the left letter. But the problem is that it's still WW. So right here, I don't think we have a problem with just doing another +1. What? Oh my god. doesn't want to remove all the way to that one pointer. Okay, let's rerun this in my head. So it'll add the letter. So we added one. We add the next letter. Now we're on W. If the right letter is unseen, it is. Then if the character on the left side is not equal to the right letter, let's update the left pointer. If the left pointer character is equal to the right character, then okay, I think there's something wrong with the condition. I'm so close.
Let's solve leak that our substring does.
For while the okay. Oh, that is true. I'm not removing whatever's on in the set. Oh damn, I completely forgot. So we'll do this, and we don't need this, and another thing. What happened here? Scene that remove SL. Key error SA. Huh? What kind of error is that? What's wrong with that line? Why is the key saying key error? Yo, what the heck? Key error. What's the key error? Whatever. Okay. Now we do not need this. What's the indentation? Okay, wow, it's in. Okay, let's try this again. This makes way much more sense. So while the left is in the scene, then while the left, okay, so we're here, we see this character while the
Doesn't have any duplicate. We can potentially make it larger than it.
while the left character in scene while the right character in scene could we have done no that won't work because we're just moving to this new character, right? So and we don't want to penalize all the other characters that were in between the left and right pointer. We just want to stop at that one character. So that's why we do while that right character is still seen in the set, then we keep removing the left side until we get to that duplicate character. And once we remove all the duplicates, we could add that right letter and get the max from there. So we'll do res is equal to the max of the previous res, or the res from the current res, the current result, or minus right minus left plus 1. I don't know why +1 though. Alright. Is it just because that makes it index 1 based? And let's see, what about this guy's solution? So this guy used a map for I in range. Whatever, it's fine. So this one uses the delete, which might be faster than remove. And let's see what else. He also uses a map, which I guess it really doesn't matter compared to a set. I guess a set has extra methods, which could make it a little slower. As to this doesn't have any methods, I think. No, it does. I'm pretty sure it does. Yeah. The keys function. If I is the right side, if right not in D, then if it's not in D, then we want to add it to the set. So this one is using like a boolean to keep track of it, seems like. Is that really faster? Okay, whatever. And then we update the current. So it seems like current is the I don't really understand this one. So we got so we run this, we got I len s start from 0 to length of s. So si, not in, so that's, it can't be in it. We go right here, while the left is not equal to the right. It is equal to it, so we can skip this. And left is equal to 1. It's right here. Is that right? I'm not even sure if I got that right. L plus equals 1. I thought, but we're skipping P. Yeah, this one's not really that good, I think. Yeah, okay. I knew this was off because this part doesn't really make sense. Same thing what ChatGPT said. You move L past the old duplicate, but you never update cur from removing that duplicate, so cur can become incorrect. Y plus 1. Not sure if I had it before. So how many can I replace? You're given a string of only English letters. After a point carried, return the longest option which contains only one distinct character. So this is saying replace those two y's with x's and you get 4 x's. So over here we could replace this b and this b, and our output would be 1, 2, 3, 4. Oh wait, we could only replace one b. Okay, so we get 5. So my thought process here would be check A. Check 0 index, first index, second, third, detect the smell right here. And right here, what I would do would be set like some kind of temporary counter and update this to A as well. And then we will check B, this one, and and then basically what we would do would be once we reach right here, we would retreat all these A's, 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 and once we reach this B, we will continue from here and start counting up. 1, and then I don't think we have to restart the right pointer. We could just keep going from here, and then boom, we see that we could pass this gap using that 1k. Okay, wish there was more test cases. But we could give this a try. Alright, let's see if I can finish this quick so I could go to sleep. So same format as the window sliding. R is equal to 0. For I in range, or let's do enums. So right, not enums, enumerates and enumerate this string. Oops. And then my thought process would be, as I explained, if I'm thinking if the right character I'm saying keeping a set. I think I'm keeping a set. So let's add a set. So what my plan is, basically we have to keep going up in case we hit a character like B. So if it's B, we will have to move all these back. So what I'm thinking is we could go on here and pass this one and go on here. No, I don't think we need a set. So let's do while or for I in range okay, let's not do that, let's do a while. Well, KK. Okay, let's do KK. KK is, let's make that equal to 0. Alright, I'm doing this tomorrow. Actually, let's look at the solution.
Hey everyone, welcome. And this is a constant time character, a capital A, and then we get 4 A's in a row, which would give us an output of 4. We want to maximize the result, right, to make characters. So finding the max character is going to be big O of 26. So that's a little bit makes sense, right? We'd have to replace at least one of these 2 characters. So we're going to ensure that the number of replacements that we need to do is less than or equal to k, which is 2. Of course, that's true. So our window is currently valid. I guess I did forget to update our result. So since this window is valid, the length of the window is going to be set to the result, right? So right now the result is 2. 2 is the length of the longest it to the rich map. Every time you want to find the most frequent character and max frequency, this max frequency. But the main idea.
Okay, we'll continue with this tomorrow. I'm done. All right. Okay. Well, that was 2 fun coding problems. I think I took. How long did I take? I started at 42, so roughly 1 hour and 20 for 2 coding problems. I am cooked. Alright, well, peace. I'm out. See you tomorrow.